Measuring the flow rate through the open channel is done through the use of an orifice meter. The orifice meter is, you can't really see it, but it is below the floor of the unit here. You can kind of see the top of it through the plastic. Now, the way an orifice meter works, if you remember, is there's a restriction that is placed for the flow, and the flow is forced through a small area, and a pressure difference develops before and after that area change, and we can look, or we can use Bernoulli's equation along with the conservation of mass principle to be able to back out what the flow rate is just by knowing that pressure difference. So that pressure difference is measured with this manometer, okay? The important thing to recognize here is that the scale here is in feet. And so you see the numbers like 6 to 7. You would normally think that that would be an inch apart because normally rulers are in inches, but this is indeed in feet. And so the 6 to 7 here is actually 0.6 feet to 0.7 feet, all right? So there's a 0.1 feet difference. What we're going to do is use that measurement along with a calibration diagram that was supplied by the manufacturer to determine the flow rate.
So here we see the calibration curve supplied by the manufacturer to determine the flow rate in the apparatus. And so on the way we use this is on the x-axis we have the discharge, and that's the flow rate. It's in cubic feet per second. And on the y-axis here we have the manometer deflection in feet. So that's the reading on the difference between the two water levels in the manometer that we just showed. And so you would come over to see and say, okay, the deflection was 0.4 feet. Then we'd read across, and you're going to always look at the small orifice line here. And then you would come down and you would read the discharge value. So this would give you the flow rate. So something above 0.04. Now, the one thing to be careful of is reading this chart. You have to remember that it is in logarithmic scale, right? So the step size between 0.2 to 0.3 is non-linear, right? It's log scale, so it has the same step change as if you were to look like this 0.1 here to this 1, right? The steps are non-uniform because it's non-linear, and so even when you do the subdivisions, they would also have that same scaling